So the context for a session and the symposium overall is the scale of the opportunity. And what we're talking about in terms of scale of opportunity is that the precision agriculture market is forecast to be worth 4.5 billion by 2020. It's growing at an annual rate of 13%. So the challenge is, how do we ensure that our agri-food sector, and when I'm talking about sector, I'm talking from farmer to the processor and anybody actually supplying inputs or services to the sector, how can the sector in Ireland have access to those latest technologies? Because if you look around Europe and if you look around the world, a lot of the world's leading food producing countries, they're investing heavily in precision agriculture. So in order for us to maintain our competitiveness and to increase efficiency in the sector, we need to ensure that our sector has access to those latest ICT technologies. And the second part of the challenge is, how can we ensure that companies that want to sell into the AgTech sector, that they have access to those technologies? So for example, how can a traditional engineering company have access to the latest ICT technologies in order to develop a higher value offering? Or how can a startup who has an idea for an AgTech product or service, how can they have access to the ICT technologies? So that's the challenge that's actually facing the sector in Ireland. And a key part of how that challenge will be addressed is technology transfer. And when we're talking about technology transfer, we're talking about taking technologies which are often deployed in other sectors and actually bringing them in to agriculture. And from an Irish point of view, that's a really smart thing to do. Rather than reinventing the wheel, why don't we look at technologies that are already existing, successfully deployed and successful, and bring them in to agriculture. And from a research organisation point of view, sorry I should say Brian Foley is mine from the TSSG research group in WIT. But from a research organisation point of view, how can we support this? How can we first of all support the industry in terms of identifying technologies that are relevant for the sector? How can we support the industry in terms of evaluating those technologies? And then how can we be clever in terms of integrating existing technology to deliver a solution to industry that allows the agri-food sector or the AgTech industry to develop a new product or a new service or to increase efficiencies and competitiveness. So, as I see it, technology transfer is a key piece in terms of ensuring that our agri-food sector has access to ICT technologies, and also that we can actually grow an AgTech industry. This is a debate that's not just happening in Ireland, and I think Peter referred to it and so did Parrott. This is a pan-European debate, and there was an event in Kilkenny at the beginning of the month where the Commission presented a vision for the digitisation of European industry. And what they're talking about is digital innovation hubs. And a digital innovation hub, basically, they want to see a network of these digital innovation hubs which give access to the agri-food processing sector and to those working in agriculture, to give them access to the latest ICT or digital technologies. And what they're striving for is this ambition that a digital innovation hub should be within working distance of people who can benefit from those technologies. And also, if you look, for example, to what our nearest neighbour is doing in terms of the UK, the British government have invested £18 million in the UK Agri-Epicentre. And the Agri-Epicentre is basically designed or set up to address a lot of the issues that we're talking about here today in terms of how to give their industry access to the latest technologies. So we have a panel of three speakers. Speakers have been chosen, I suppose, from the point of view of their expertise and the different aspects that they can bring to the discussion. First of all, we have Frances Cleary. Frances is a colleague of mine at TSSG. She's worked in the research group for the past 14 years. She's been involved in various technology developments, including cybersecurity, intelligent transport systems and smart mobility. She currently is a technical lead of one of the research units at the TSSG, and Frances has a lot of experience of seeing how various technologies have been successfully employed in other sectors. So I'll ask Frances maybe, the format will be that each speaker will speak maybe for 3 to 5 minutes, and then we'll open it up to discussion. But I'll ask Frances maybe to give an indication as to some of the technologies that she sees as being potentially applicable in agriculture.
Thank you very much, Brian. Well, as Brian stated, I've worked currently in the ITS smart mobility sector in particular. There's been a huge, I suppose, drive on the leveraging of ICT technologies in this space over the last 6 or so years. So it's moving very rapidly. So a lot of the technologies we see that are active in this space are equally applicable and applicable across to the AgTech sector. Say that for the likes of the precision agriculture type area, you have the use of, look at technologies in the area of, let's just say, drones, robots, smart equipment, more smarter platform management, development techniques or technologies that can be used across the board. And they also look at various different sensors in the space, also I suppose that can be leveraged from an input point of view. When I mean input, again, to use sensors to monitor and track your say fertilizers and pesticides, etc., in the AgTech space. Now, in the ITS smart mobility sector, on average, is roughly around 17 startups on a weekly basis being generated using these such ICT technologies. So again, there's similar opportunities in the AgTech space for such a level of impact, etc., to be adopted and utilised, and for Ireland, etc., to be, I suppose, become a key player in this space. There's also disruptive technologies, again, as was mentioned previously, around the supply chain. Again, from the farm gate to the table, and what can be leveraged here. Again, that's focused more a bit around the traceability from the packaging processing technologies, and what can be used again, which from the waste reduction management technologies. I suppose at EU level, there's a lot of research ongoing, a lot of open calls with projects that kind of look at NFC technologies. They look at the QR codes, and they look at kind of motion sensors or temperature sensors, and integrating them all together to make a more intelligent, integrated product that can be used in such waste management and tracking technologies in this space. Again, the leverage and use of assets in the AgTech space, how to, I suppose, leverage them and make the asset sharing more intelligent, and new production, new business models around this. I suppose, as was stated in the first panel session, again, these kind of technologies, in order for them to be adopted, they need to be clearly visible, and they need to be usable, and that the immediate impact needs to be more, I suppose, immediate and visible to the farmer and the end user and the various stakeholders involved. I suppose, just to give you a very brief example of one very simple thing that we're looking at in TSSG, the group that I currently work in, we have some people that we're running a project with the Road Safety Authority. It's around pedestrian and cyclist detection systems, and specifically what's out there on the market, what's usable, how they work on HGVs and buses. But what we're doing is we're looking at the technologies that they use in the space, the ultrasonic sensors on the more lower cost products, or we're looking in the image processing type technologies that they use in kind of more advanced more expensive type systems out there. And we're extending the scope of it beyond just the normal transport domain into the agri-tech space as well. We're looking at, say, the requirements or needs from the farmer's point of view with regard to combine harvesters, loaders, tractor trailer type equipment, and what, I suppose, blind spots, what kind of systems can work for them, or what's on the market and what actually doesn't work, and how we can actually take the core technologies and build on them for a next generation product in this space that's more applicable, again going back to the farm safety, farm health point of view. And so that's one very simple thing. So we're doing a current project in that space, and some quite interesting results are coming out of it, and the potential for a new product in the space that's more useful and beneficial to the farming industry. Alongside of that, again, sensors have been mentioned quite predominantly in the previous panel session. They're core to nearly every sector across the space. What we're specifically looking at is more low-cost options, low-cost systems, low-cost platforms. The emphasis is on more disposable type sensors and replacing them and deploying them again. But again, having a low-cost system in place that has more impact. Again, we're specifically focusing around the fertility soil indicator type area at the minute and what we can leverage here. But again, multiple use cases that we can apply the same type systems using anything from turbidity sensors, motion sensors, humidity sensors, and the likes of small, more miniature Raspberry Pi computers, and what we can put together as a system and promote and deploy. So again, some very interesting work that the core group is actually doing there in that space. There's a huge amount of, I suppose, focus across different sectors on kind of more IoT integrated data development platforms that can be used and leveraged. I see it quite visibly and active in the smart transport space, but it has huge potential to map across to the AgTech space. Again, I suppose to have these platforms in place, just to give you an awareness, there's a lot of research going on in the 5G space as well for the communication infrastructure management side of things, for the back end that needs to be in place in order for these communications to be in place. It's estimated that I suppose 5G will enable approximately, I think it's around $12 trillion at the global economic impact by 2035, and they state that around 6.4% of this will be specifically for the AgTech space. So, I mean, the agriculture use case is one of the core use cases in the 5G technology. So this is coming down the road. It will enable the services to work in a more efficient, more, I suppose, operable and more realistic conditions. So it's one to watch, one to keep an eye on. There's a lot of businesses pushing services and new commercial products in the space in order to align with the 5G rollout at EU level as well. So I mean, that will automatically stem and push new sensor development opportunities, platforms in the space. It will lead to new enhanced services around crop communications or I suppose optimization and feeding schedules and different types of services that can be provided. And just to wrap up, Brian, there's the other concept, as it is in the ICT space in general, everything is as a service. This goes back to, I suppose, Willie's comment around the service part of things. We have infrastructure as a service. In the mobility, in the transport space, we have mobility as a service. So again, it's going back to your farming as a service concept and model, and what can be used there, a more integrated approach, not only via partnerships of farmers and the community and the stakeholders, but also leveraging the core technologies and how this can create a more integratable, operable platform to, I suppose, generate new services, new businesses, and new business models in the space.
Okay, thanks, Francis. Now let's just from one research group. Okay, so there's a huge pool of technologies that are already developed, applied in other sectors, which if we're smart about it, can be brought into agriculture and can basically cut lead in time for us to develop an a vibrant AgTech sector and to bring those technologies to bear in agriculture. The next speaker is Cleary. Ethan is from the IFA. He's the head of the IT strategy in the IFA, and he's responsible for driving the innovation and digital agenda for Irish farmers at the EU and national level through the IFA. And we have worked previously in project proposals with Ethan and found him to be an excellent guy. And I think the idea of him involved in this panel discussion is to give a user perspective, because I think the point was already made by Frank that we can develop all the technologies we like, but unless there's an appetite amongst users to use these technologies, we're not really taught to understand the user perspective. And secondly, I know that the IFA has done a road mapping exercise where they have identified specific technologies that are particularly of interest to them. So,
thanks, Brian. I suppose in the last 18 months, going over to Europe as part of TSSG, which is the European Federation of Farmers, we're starting to notice that there's a convergence of technologies from consumer tech space kind of folding in that are reaching a level where they make practical sense within the farming community. The big kind of, I suppose, leveler has been the smartphone. You think about it, there's 5 billion plus people with phone connectivity in the world. Out of that, there's only 3 billion who have smartphones. That's kind of changed the paradigm in terms of, what's the first computing experience a lot of people have. It's not a tower or a laptop that's chained to a desk. These are now mobile, kind of high-powered, sensor, driven devices that have new forms of user interface, data entry, data collection. So what we've kind of seen, I suppose, going back maybe the last 5 years is that, multi-touch was a big kind of change. As opposed to having to use the old Windows, icons, menu, pointer approach. Now it's in your hand, you could pinch, zoom, you could shake your phone to undo a mistake. It opens up different approaches to how we interact with technology. And I suppose voice has become bigger and bigger in the last few years as well, and we've noticed, even amongst our members using it as a means to get weather updates while traveling. So like 20% of all Google searches are now done by voice. And also the camera, which I'm calling an image sensor from now on, because maybe my generation and previously we would have thought of camera and photos as mementos, something that was tangible that we put in a photo book. Now images are disposable, they're haptic forms of communication, they're ephemeral, it's not the same way we would have approached it. So those kind of 3 different paradigms have kind of come together and has allowed these new approaches that, from what we're seeing, fit into the farming model maybe better than traditional enterprise kind of models. So this has brought together this kind of idea of artificial intelligence, right? And I'm not talking about, Arnie Schwarzenegger in Terminator 2. I'm talking about something a lot more prosaic and mundane. Because you're carrying a device around with you all the time, you're generating loads of data. And with that data, you can use fancy algorithms to train that data to classify stuff and to predict stuff. And that's kind of pretty powerful. Like some of the examples we've seen is, let's say in, I think it's in Cambridge, that they have now used only 500 photos to actually get to 80+% accuracy in diagnosing the pain that a sheep could have, whether it's rot foot or something. And that's done by looking at how they tighten their face, close their eyes. So you're getting to a pretty decent level of accuracy. If you look what's happening in the kind of tillage side, which is pretty, it's a lot more advanced given the kind of the scale that's involved. You look at what, I think it's a company called Blue River Technology, which allows you to actually identify on an individual level what is a weed, what is a crop, and only apply the correct chemical to that area and avoid the soil completely. But that's only feasible with data that is available, that's out there, that's been collected. Like the big thing is, I don't know if people kind of come across it, but Google years ago used to have a CAPTCHA, which is where you sign in to get into a particular service, and they ask you to classify street signs. And you're kind of wondering, why were they doing that? But that all fed into, I suppose, the next big level or next big kind of innovation, which is automation. Because by you training that data, it allowed them to beef up their algorithms, which allow them to now actually have a kit for self-driving cars, which is going through rigorous testing as well, I suppose, at the moment. So, the big thing underneath all of this is we've gone from an era where the computer could read text and numbers in the old database model, right? We're now getting to a point where we can read images, we can read voice, we can read video. And that opens up a hell of a lot more applications. It's another level of abstraction. It removes the kind of manual input that's required by this level of automation going in, whether it's, the hands-free hectare experiment in the UK where they're trying to grow a crop of spring barley without ever, a human ever touching or placing a foot inside a field. Right up to the examples I was talking about there in terms of being able to identify crop species down to a particular level. So it's that conversion of technology. This is why I'm pretty excited. I know that the latest McKinsey digitization report had agriculture at the very bottom, but that also means that we can close that gap quite quickly because the kind of predecessors are there in terms of technology, and it's about how to actually combine that together.
Our third speaker is Tommy Mitchell. We met Tommy for the first time about a month ago. I think he came across from Scotland to talk to us about a project. He's Group Technical Director of NVT, a technology service integrator based in Scotland. He's worked in the IT industry for over 30 years. And he's worked on delivering large-scale networks in challenging environments such as major sports events, industrial applications, and rural connectivity. And it became apparent, again, the reason why we invited him to participate in this panel, is that it became apparent that a lot of the challenges we're talking about here in Ireland are very similar to challenges that Tommy has come across in the UK and Scotland in particular. So maybe you might talk to us a little bit about what the feeling on the ground is in Scotland, and secondly, more specifically, how Scottish companies are engaging in this new UK Agri Centre in terms of accessing ICT technology.
Okay, morning everyone. Please let me know if you don't understand my West of Scotland accent. It was quite interesting to be asked to participate in a discussion about transferable technology, because I came to AgTech through a very circuitous route, but most recently through sports. So we were involved in technology in fairly major sporting events, the Commonwealth Games in Glasgow, the Ryder Cup at Gleneagles, the European Games out in Baku in Azerbaijan. And that's contextually it was very different, but from a technology standpoint it's pretty much the same. And in a lot of cases, particularly in the Ryder Cup and Commonwealth Games, what we were literally doing was building enterprise networks in fields. And we were then approached to say, well, you know, a field's a field, right? So if it's not broadcast and timing and scoring, what if it was other applications, literally in fields? So and that introduced us to the University of Strathclyde, and they had an application. They had a spin-out business called the Silent Herdsman, you may have heard of, which is effectively a monitoring system for dairy herds. And that was based on some reusable technology, effectively accelerometer technology that you might find in your smartphone. And when your smartphone, if it happens to be attached to an Endomondo application or a Fitbit application, then it tells you about how your movement, but the same technology with a different application applied to cattle will tell you about its movement, and it can be interpreted in a different way. What it all has in common is, is a requirement for connectivity, which is where we come in. We're not experts in the applications or the interpretations or the generation of the data, but we're actually pretty good at the transport of that data from the source to the destination, where it can be interpreted and manipulated and provide that decision support that was mentioned in the first session. So through that involvement with Silent Herdsman, which is a very effective technology, and it involves a collar being placed on the animal with some accelerometer, 3-axis accelerometer that detects the movement of the animal throughout the day, and it records that. But the data can only be collected when the animal returns to, or when it comes to a parlour to be milked, because there's no infrastructure in the field for it to send the data and for it to be transferred. So that was creating a gap. So what we were asked to do was to look at how do you extend the network, literally into the field. And there's a number of challenges around that. There's not an awful lot of power or cabling or even structures to mount networking kit to. So we had to come up with something that was practical, very robust, reliable, but very cheap. Because if it's unaffordable, it doesn't matter how good it is, right? So we worked on that and looked and had to figure out how to deliver power to remote devices using renewable sources, how to make it cow-proof, vandal-proof, theft-proofed, but also do it very inexpensively. So you can't afford to send somebody out there to repair it. It has to be effectively disposable. And through that project we got exposed to other applications, other AgTech applications. We said, okay, well if you can deliver the network in those locations, what else could you use it for? And that led us to the Agri Centre, which the University of Strathclyde have also got some involvement with. And that project is about bringing together academia, AgTech industry, and farmers themselves together in working farms to test, develop and improve the whole range of technologies. And the form that that's taken is that the participating farms establish a collaboration centre, which sounds very grand, but it's effectively a lab which typically exists in a porta cabin that's dropped onto the site, where the academics, so researchers and commercial industrial suppliers can come together in a real life situation and test and develop and get feedback from the technologies that they're working on. And our involvement in that is that we provide that connectivity into the farm. So in lots of cases, and we understand it's very similar here in Ireland in that rural is rural wherever you happen to be in the world. Rural means far from the metropolis. So connectivity, and it's wonderful hearing lots of stuff about what you can do in the cloud. But if the only cloud you see is the ones in the sky and not Google, then you can't get off first base. So the first challenge for us is to look at how we can connect these fairly remote locations to the internet, and there's a number of reasons for doing that are not just about the transfer of the application data, but then extend that connectivity across the property in various different forms. And so what we've come up with is a toolkit using fairly commoditised pre-existing technology products that we've adapted into a kind of battle box that allows us to then to connect that farm to the internet and to connect within the farm so that the applications can be tested as fully as possible. And what we're seeing is that some of the benefits to that, so there's one farm in particular that's quite advanced in a number of areas in dairy, where they have very sophisticated milking robots, for example. So that the cows choose when to be milked, and they just wander in and get milked, and this robot takes care of it. They also use the silent herdsman system to monitor the health of the animals, but they're completely disconnected from the outside world. So if something goes wrong with either of those systems, they have to do it the old-fashioned way: phone up the supplier, wait for them to get on the phone, or actually send somebody to site. So that lack of, despite having all this very intelligent, highly efficient technology, is great when it works. But if it doesn't work, when it doesn't work, then your dependency has gone up and your ability to support yourself goes down. So that establishing that outside connectivity allows those suppliers to basically connect remotely and assist in real time and be able to participate in making sure that the benefit of having that investment in that technology is realised every day, and you're not exposed to outages. So that's been quite a transformational event for this farm in particular, because those investments that they've made are fully available all of the time, and the support and development and improvements that they can make by being connected has been quite staggering, actually. So that participation. So what's going on? So we're involved in a group of 17 farms initially across the whole of the UK. So from the kind of Central Highlands in Scotland down to the southwest of England, across a range of different. And from our point of view, it doesn't make a difference what the farm's purpose, what particular area that it's involved in, because our interest is in making sure that it can be connected and support whatever applications, whatever technologies make most sense to that particular business on a one-by-one basis. So the arrangement that we have is to basically to work with the Agri Epicentre and the industry partners to establish these collaboration bases on the farm and to provide the connectivity across the property so that they can evaluate and make use of and start to adopt the technologies that are going to be of the greatest benefit to each individual business. And that's proven very successful. There's a willingness amongst the participating farms to be experimental. There's a contribution from academia and from industry to provide the expertise and the resources and the early stage technologies to get them into these live environments and prove them and refine them and adapt them and just make them more available, which ultimately leads to a sort of faster development cycle and a lowering of costs. So the more we kind of take out the variations, and improve the tolerances and fine-tune the applications themselves and the sensors and the combinations of sensors and how the data is processed, then that accelerates the sort of time to value, and that's proving to be very successful. And it also helps to sort of drive the cost down, because from our point of view, we are not inventing anything. We are adapting and reusing existing technologies which are always coming down in price. And looking at new ways to do the bit to fill in the gaps. So power is always a challenge. So if you're if you happen to need some coverage somewhere that's 2 kilometres from the nearest building, how do you get power at that location? So those are the things that we are helping to solve as part of this project.